Hi, in these final two chapters, we're going to talk about the oceans, coastal processes, and coastal formations, as well as glaciers. Coasts, especially being in Virginia, you're in a very fickle area when it comes to preserving our coasts, especially Chesapeake Bay and all these other areas which are susceptible to global climate change, rising sea levels, as well as environmental degradation, air quality, water quality. So I thought this was neat. This is a satellite image or composite satellite image of the lights in the world. So you can see where there's lots of lights, less lights. Thought it was kind of interesting where we look at the allocation of resources. This is San Juan, Puerto Rico, right here, and so when we look at the chemical composition of seawater, ocean chemistry, how we're changing that, and how it may be impacted by human activities. So the physical structure of the ocean varies by depth, the average temperature, salinity, dissolved carbon, dissolved oxygen. There's a number of different components of seawater that's made, that's where different things live based on light and whatever. But we can also look at the coastal navigable rivers, so we can see what's navigable. So I've been to Arkansas before. I've seen boats go up the Arkansas River all the way to Oklahoma, so where we can move things large scale. So these are all the counties which are navigable. We can look at the ocean floor, dissolved gases, but when we talk about the coastal environment, it's very fickle. We've got the shoreline, we've got the coast, and the sea level refers to the mean or the average elevation of water relative to the land surface in the ocean basin. And we really need to be aware of how human activities alter and influence this system. Atmospheric winds, solar energy, those are things we can't change, but we really need to focus on the things that we can change. So this is the area, especially when we look at the ocean right here, these littoral, littoral areas near the coastline, the ocean topography, and then tides. Tides change. In Canada, there's some hot tides that are up, 10, 20 feet. Here, they're a little bit less. In the United States, a good bit less. And we've got spring tides, neap tides. How do we utilize tidal power? Because essentially, a tide, obviously the Earth is about 71% water, so it gets pulled in the direction of the moon. That's all the tide is. It's just the manifestation of gravity. We've also got waves, undulations in the water generated by wind friction at the surface. So you can see the generation of waves and how these are going to, weather erode the particular coastline. And then we have different currents. We have our longshore current, our coves. You can see a lighthouse here because of the changing dynamic of it and the directions of those. And you can see this is Cape Cod, formed by glacial features. And then you can see all these inlets and whatnot here. Some of these are relatively young, like tens of thousands of years old, and we talk about billions of years old. And we have moraine, which is something that's left behind from a glacier. And then we have a tsunami, which is typically generated by earthquakes, landslides, submarine volcanic eruptions. It's just the release of energy. That's all it is, essentially, just like an earthquake. But we can see we've had tsunamis. 2016, 2011 in Japan killed about 20,000 people. 1964 in Alaska. 1960 in Chile. And then, of course, we remember the one here that occurred off the coast of Indonesia, killed about 250,000 people. And you can see how long it took to travel across the Indian Ocean. About 300,000 people here, killed people in Kenya, Tanzania, Somalia. These are over here. Okay? And when we look at some of these countries here, they're not the richest countries. Well, Australia is pretty well, well off here, but they're not the richest countries, so they don't have the infrastructure in place for, tsunami warning systems and all these other technologies that maybe Pacific Ocean might have. The 2011 Japan tsunami occurred right off the coast, so they did have some tsunami detection in place, but it was too close for people to get word about it. So when we talk about some of those dynamics. If you ever see the water go out really far, go in the other direction because it's going to come back in. So you can see this is from the 2004 tsunami. You can see a before and after picture. I think I've shown this before. And you can imagine the erosion, the deposition, and the landscape modification that something like this does. And you can just see some other, coastal sea forms that we talk about, notched cliffs, sea caves, sea arches, sea stacks, the tidal inlets, lagoons, barrier islands attached to these. We have barrier islands that occur along the eastern part of the United States. Jersey Shore is a good example of barrier islands before you get to mainland, which are literally just feet in elevation. You can see the barrier islands here in North Carolina, off the coast here, that eventually got up into Virginia and Virginia Beach. And you can see here the Jersey Shore here. These are all houses and summer homes and whatnot built on this barrier island that's probably about 10 feet in elevation. And we've got biological processes such as coral. So as you can imagine how fickle that is if we change the salinity or the content of the oceans, what that's going to do. And then we have these coral formations, coral islands, a lot of these out in the western Pacific Ocean. This is Nicamaruru. And then the human impacts. About 40% of the Earth's population lives within about an hour's drive of a coastline. This is Fiji. And then you can see the importance of nautical charts and how these always change. This is Crater Lake, so you can see where Crater Lake's deepest. This is those pictures that I showed you before. And this just talks about the importance of mapping. Venice, Italy is an area that is suffering, or maybe not suffering, but it's seeing the impacts of rising sea level because it's literally at sea level and it's sinking. But there are some other areas too. Chapter 17, last, talks about glacial and periglacial landscapes, rivers of ice, glacial processes, paleoclimatology. Basically, glaciers are rivers of ice. We have continental glaciers, which are like ice sheets on about 80% of Greenland, 90% of Antarctica, ice caps, ice fields, and these moving ones such as your glaciers. We'll look at examples of these, but you can see the Piedmont foot of the mountain right here. We've got these fjords which are formed, valleys, ice caps. So these are some of the terms attached to them. This was the ice cap that kind of influenced the northern part of the continental U.S. 10, 20,000 years ago. So we talked about some of those moraines attached to the coast over here, and you can see what the coast looked like not very long ago in geologic time scale. We have snowfields, ferns, glacial ice, and so you can see some of the terms attached to glacier and glacier formation. Accumulation zone, equilibrium line, and then you can see that constant battle between gravity and the forces that try to keep it in place. And this is where it accumulates, force, gravity, and then the terminus and the calving. And it basically flows, and they flow. They're extremely slow. I'll show some pictures from a trip that I took to Alaska recently. And then you can just see some of the effects of glacial erosion. And these are just some of the terms that you can look at. Some of the Alpine glaciers, these U-shaped glacial troughs, moraines, and these are typically debris which are carried from somewhere, taken somewhere. This is not Mount Shasta. I believe this is Mount Shasta in Northern California. And this is the Mendenhall Glacier in Alaska. So this is the end of the glacier where I'm taking the picture from about 50 years ago. That's where the end of the glacier was. So this glacier is currently retreating on the order of about, a few feet per year. There are some glaciers in this area which are actually growing in size, but most of them are shrinking in size. Here's another one here, and I don't even think this calves anymore. Okay, it kind of ends at this land right here, and then most of it kind of melts and flows into this arm of the, this is in the Gulf of Alaska, Pacific Ocean, I think it is here. Okay. So you can see examples of your moraines. And I'll actually show you an example of this here while we're here. And this is Mendenhall Glacier in Alaska. So if I zoom out. So this is Juneau, Alaska. This is actually the capital of Alaska right here. If I zoom out a little further, this is southeast Alaska. Your big city, Anchorage, is way over here. Fairbanks is kind of up a little bit further north. But the interesting thing about Juneau is if you look at the roads here, the roads literally stop. There's no, there's roads here, but if you go far enough north, the road literally stops. So in order to get here, you have to fly your car in here, or you can take a boat and drive your car into a boat here. But you can see there's lots of roads and whatnot around here. Well, this is an interesting dynamic, but this is Mendenhall Glacier right here. And you can see the area where I was. And if I were to zoom out, you can see this, and you can see why the road stopped, because we have this big glacier field right behind Juneau, Alaska, extending over into Canada. And you can see how big some of these are here. Okay, you can definitely see how big some of these are. Okay, but you zoom in, you can start to see, Alaska, and it's kind of tucked up right against some of these mountains. And the road, and this is a big island called Douglas Island. Real quickly, while I got a little bit of time, I was over here in Glacier Bay, in this area here, and these were some of the glaciers that we were looking at. And some of these glaciers are actually increasing in size. Some of these are decreasing in size. So we can kind of go up. This glacier here barely makes it to the land anymore, while this one is literally coming all the way out, this Marjorie Glacier here. So this is an area called Glacier Bay. It's a national park. It's largely accessible by boat and maybe a little bit by plane here, but you can't drive here. And there's a little town here, somewhere around here. I guess this is the town here where people actually live. But you can see, some of these relatively tiny areas. A lot of it's park staff, but there are some indigenous populations there. But one of the things that they did say is that these glaciers have been retreating since the 1700s. These glaciers went out to this area here, and then in the 1700s they started retreating. Now obviously this isn't because of man-made or anthropogenic activities. It's got to be something else. So a lot of times when we hear the term, global warming, it's man's activities combined with, some of the natural uptakes or, uptakes of everything. In the 1700s, most of the people who lived in the towns here actually moved over to the other side of the bay, and this is a town here with a large indigenous population. So while I'm here, and that's about it. This is Wallower Lake here. You can see some of the V-shaped rivers, valleys rather, and this is in northeastern Oregon here. So this is Wallower Lake, and this is part of your glacial landscape. And these are some pictures from that area that I've taken in the past. This is Patagonia down in Argentina, Mount Rainier, and this is Mount Rainier once again. So like I said before, imagine if this were to flash melt, where would all of this go? So periglacial cold climate processes, landforms, topographic features along the margins. Okay. So you can see that, the melting of the ice caps or whatnot here, and humans and periglacial processes.